think it depends on what you do. Anyway. So, let us forge ahead, do more of the same. So again, actually today we'll graph rational functions and do a little bit more. We'll also start thinking about solving rational inequalities. Really, if you can do one, you can do the other. I mean, in some sense, I think we could have started with solving rational inequalities and then transitioned to graphing. That might even be a more logical order of operations because solving inequalities requires less nuance than like graphing. Graphing is kind of, more. So here's an example. Let's look at f of x equal to x squared minus 16 over x squared plus, let's say, 3x minus 4. All right, let's graph this thing. Try to find any horizontal or vertical asymptotes, any holes in the graph, label them. So what's the first order of business? I think the first thing I would do would be try to factor it and see if there's any kind of like simplifications that go on here, right? So we've got x minus 4 times x plus 4. And downstairs rather, we've got what? X minus 4. X plus 4 rather, times x minus 1, right? Does that work? Mm-hmm. Yes, the x plus 4 would cancel. Let's see here. So we'd have x minus 4 over x minus 1, right? For x not equal to, 1, of course, but also what? Negative 4, right? So let's see here. Let's talk about this. So the 1 is going to give us a vertical asymptote, right? Vertical asymptote at x equals to 1, because we have a unopposed division by x minus 1 in the denominator. It's going to give us a vertical asymptote. But on the other hand, the x equal to 4, x equal to minus 4, that's just a hole in the graph, right? Because we had a factor upstairs and downstairs, and they cancel out. So this is going to be a hole in the graph.
So is that how you know when it's a hole in the graph? Is it'll be both on top and on bottom?
Right. But that's not. You say so. She asked, "Do you know it's a hole in the graph if it's on the top and the bottom?" Let's, hypothetical for a second here. Suppose you have g of x equal to stuff times x minus, constant. Let's say c to the p divided by stuff times x minus c to the q. Is this, and supposing that the stuff also has the stuff is a polynomial which doesn't have any x minus c factor in it, okay? So like all of the x minus c factors are put into x minus c to the p. All of the x minus c factors are putting x minus c to the q downstairs. Is this a hole in the graph? Is this a vertical asymptote? Like, what's the story? So if q is strictly greater than p, then x equals to c is a vertical asymptote. So like if the denominator was x minus c squared and the numerator was just x minus c, then you'd have a vertical asymptote. That's what happens. On the other hand, if q is less than or equal to p, then y equals g of x has hole in graph at x equals to c. And I mean, I can tell you more. Where is the hole? And by the way, if q is strictly less than p, right, then I can tell you that c comma 0 is the hole in the graph. Let me give 3 examples, and then I'll return back to our example ones. But this is a good question. We should just digress and try to deal with this. Like, example 1, if I had y equals to, say, x minus 2 over x minus 2 cubed, then this is just 1 over x minus 2 squared, which is got a vertical asymptote at 2. It's one of the, I call this thing the volcano graph, right? Like that. That would be the case that the factor in the denominator wins. All right? Example 2, if they're equal, like that, for example. So here they're equal. Then this is just equal to the constant function. This is like one of my first examples, right? This is just equal to 1 if x is not equal to 2, and it's undefined for x equal to 2. So what that is just hole, like that. And then example 3, if we had y equals to, say, x minus 2 squared over x minus 2, then the hole in the graph is at the x-axis. It's actually 0. Here the hole is 2, 0. So basically, this is the line y equals x minus 2. It's the line y equals x minus 2 with a hole right there. That's it. That's all that can happen, pretty much. Now, of course, this gets souped up because you're multiplying it by stuff over stuff, right? But that's what has to happen at the place where we have like a matching factor. One of these 3 cases. Is there anything else that could happen? I think that's pretty much it, right? I mean, you can't imagine another case. So you guys excited about not coming back after Thanksgiving?
Yep.
Definitely. Yeah.
So we take, how are we going to do finals?
Oh,
Those are going to do it the week
It's almost like I had already rescheduled the final to the week before Thanksgiving for no seeming reason, like a couple weeks ago. Almost like I was just some sort of, you know.
It's online, right?
No, in this room.
So we're gonna have, when is this test for this chapter?
I announced it before.
Is it next Wednesday?
Next Wednesday?
You're asking me tricky questions like when next test is. That's a hard question. Give me a second here. Uno momento. Por favor.
You wanna sit over here? Yeah. Okay.
All right. So there is still a final during the final time. It's just it doesn't replace your test grade. The one that replaces your test grade happens in class here. So I had course planner major revision announced on September 27th. There I told you that final exam part 1 will happen November 16th, and final exam part 1, part A and part B are November 16th and November 18th, which is just shy of a month from now. Test 3 is on November 4th. So, yeah.
Can the final only help us, or can it hurt us as well? Like, you said it would replace a test grade, but will, so.
Oh, I mean, if you got an A on the test, you make a C on the final, I replace it with a C?
No.
I'm open to that.
No, that's not what I said.
I'll call it Jared's policy.
Hold on. That's not what I said. Let's say, you said it would replace, like, let's say on the first test we got like a 0.
Uh-huh.
You said if we did well on this final, it would replace that first test.
That is true, yeah.
Right. So if I got A's through all the tests, and I just don't want to do the final, or like I fail the final.
Oh, if you get A's in all the tests and then if you don't do the final, you probably can't make it past like a C in the course, I guess.
Oh, so it will hurt me if I don't do the final.
Yeah, I do want people to do the final, yeah. But honestly, if you've made an A on all the tests, then the final would just be like boring. So
Yeah.
C is passing. It depends on your degree program, right? Because like some programs you need a C in order to get to the next course. Like any math program that was doing right by its students would require you to have a C in this course in order to go to calculus. Because if you have a D in pre-calculus, it means that you're in a bad spot. I mean, because if you're going to use that material past this course, it's not great. Yep.
If we do have a D in this course, will we have a chance to bring it up?
Yes. I mean, whatever your current average is, if you do better on the final exam, the in-class part, 1A, B, the one that happens in about a month, that can definitely bring up your grade.
What would you say we had to make?
I'd say you have to make, like a high C at least to like something like that, But that's not inconceivable because I do post solutions to the test. You can go back and, try to figure out what it is that went wrong and you can fix it.
Do you think we get a study guide?
The study guide is the test. I mean, the whole class is the study guide. So, yeah. But no, I don't usually make a particular study guide. I mean, pretty much the final is comprehensive. But that said, I typically focus on the material I've already put on test. So if something's been omitted from a test, it's very likely it's omitted from the final. Like it would take a student having a particular conversation with me to like twist me into putting it on the final or something, Yeah, like that. I don't know, once I once challenged, I don't know if I may have told you this, guys, or not. I think I probably told you, but I had a class and I went to the professor and I told him something wasn't going to be on test 1. And he said, why? And I was like, because you don't test on proofs. We don't need to know those. As stating as if a matter of fact that even though he spent 30, 40% of the class on going through proofs of the results that we used, right? So to say that we're not going to be tested on that and it doesn't matter is very insulting. I knew this. Yes. Now, he didn't put it on test 1, but he did put a proof of the Lagrange equations on the final exam of that class. Oh, yes, I've been practicing for it all semester. In fact, it's how Crazy Paul passed mechanics. because Crazy Paul practiced how to do that with me. The rest of the students came out of that final going, "What was that? What? What was that question?" And I was like, "That was my question." So you can play those games, but
Okay, so the final can't hurt you though, so it's what?
the final can't hurt you.
I say can. You say can.
Well, I mean, it's points in the course, so yeah. I mean, you want to do better on the final than you've done on the test, otherwise it's going to drag your average down, right? But as long as you have studied and you come and you have a sheet of notes, right? So you can kind of collect your thoughts. And typically, I will say aggregate, like as a class on a whole, this policy I have of replacing test grades with the final exam grade, if helpful, it usually raises the average of the class about 4%, something like that. But there's a couple of students that it'll change their grade from a C to a B, or from like a D to, even a D to a B. Like, and those are exactly the students I wanted to help too, because it doesn't so much matter to me what you know right at that test. What matters to me more is what you get, what you understand leaving the course, Which is why I'd really like to have a policy that if you make a C on the final, I give you a C in the course, but I cannot do that. You've already earned what you've earned. So, yeah.
Is test 3 going to be the last test before the final exam?
Yes, test 3, which I was just getting to, test 3 is November 4th.
And after that, we're just going over
Then, yeah, then after that, we're covering stuff about exponentials and logarithms. Let's see here. And I did say though that I think I've already promised that the final exam part 1 will only cover the material up to test 3, which means it pretty much only covers up to what we're covering today. Yeah. So what's on the final exam part 2, which is worth 75 points, right? So if you don't understand anything about that, it can definitely make you drop a letter grade, especially if you're in the bubble. So, but what's on the final exam that will be, through a Zoom meeting, right? I proctor it by Zoom, post the PDF, you'll work it out, and then email me your solution is what we'll do. And I think that's supposed to be December 7th from 11 to 1, all right? I am going to be somewhat inflexible about that. If you're like, I got a job and I work during that time, so I can't come to your final exam, I'm going to be like, well, that's too bad, you get a 0. I mean, I probably won't laugh, but do not be otherwise engaged during the final exam time, please. You will be able to take it online, but it'll be like during the official final exam time, which I think, if my course planner here is correct, and it should be because I looked it up on the university schedule to start with here, it's supposed to be December 7th from 11 a.m. to 1 p.m. The final exam will be just focused on the material after test 3 alone. It's December 7th. So the final exam will be on, what was I here? Material in chapter 4, which I'll probably start talking about Friday, because I think it's healthy for you guys to see it talked about in class. Yeah.
Also, it says that we're supposed to conduct classes virtually for a couple of days after Thanksgiving break. Is that?
I'll do something. I'm not sure what exactly we'll do, but we might really not need to do that because we might be through the material by then. So I might just hold a Zoom help session or something. Yeah. Which is kind of miserable, but anyway. Okay, so let me erase this and get back to our example. Great questions. I'm glad we had this conversation today. Excuse me. Yeah, it's just the chalk, don't worry. Actually, out of positive 4. Thank you for trying to steer me back to the math. That's because f of 4 is equal to 4 minus 4 over 4 minus 1, otherwise known as 0 over 3, which is 0. So this is the other thing we should keep in mind, is if the numerator has a factor and it's unopposed, then that can give us like a 0 in the graph. I mean, an x-intercept, right? So we've got an x-intercept there. And then how do we figure out the rest of the graph? A whole and negative, oh, a whole and negative 4, right? Let's see here. So the reduced function is something that's sometimes useful to talk about. The reduced function is what you get from canceling out any factors, all right? So it's not the function, but it's what would be the function if you could sort of just ignore those factors and like fill in the holes. Basically, this is the graph of this is the actual graph we're interested in with the holes filled in. So that's kind of cool because you can look at the reduced function and plug in the value for the hole, which is what? -4, right? And that will tell me where the hole is. Apparently, 8/5. So that's where the hole the hole would be at -4, 8. What's 8/5? What, 1.6? It's kind of over here. Eight-fifths is 1.6, right? And what's the y-intercept of this thing? What's that? 4? Oh, I think you're right, yeah. So -16 over -4, and I was like, 4? I thought it was, oh, yeah, that's 4. All right. Oh, plug in 0.
Is that what you do with find out why?
Yeah, anytime we want to find the y-intercept of a function, we just plug in 0. The exception to that would be when 0 is not in the domain, right? If 0 is not in the domain, it's like a hole, then we'd have to look at the reduced function and plug in the whole value to the reduced function. I just introduced this idea of reduced function to you guys. That's like a new thing, right? I've been kind of dancing around that idea. 4, oh man, 4's, it's up here. Oh, not the scale? Okay, so this, and here is 4. So apparently, we've got something like, oh, wait a minute, do we have that? I'm assuming it goes to 0. Does this go to 0? What's the horizontal asymptote for this one? I think there is one. Unfortunately, my graph is, I've run a chalkboard over here. But actually, we can show that there's a horizontal asymptote at y equals to 1. And to see that, notice that f of x is equal to, well, like 1 minus 16 over x squared divided by 1 minus 3 over x minus 4 over x squared. So divide by x squared above and below. All right, if we do that, then that's the formula we get for the function, right? What happens as x goes to something really, really large, positive or negative, right? So this just goes to 1 minus 0 for 1 minus 0 minus 0, which is 1, as the value of x is much, much greater than 0, right? Or you could say as x goes to plus or minus infinity. So you might be wondering then, can you see that without doing that algebra? I think you can, right? So more generically speaking, guys, if we have f of x, it's got like, you know, a x to the n plus stuff, you know, lower order stuff, you know. We call that an. Come on. And we divide by bn, x to the n. Then this guy has y equals to an over bn as the horizontal asymptote. So that's basically what you're looking for. So this one, because the degree of the numerator and the degree of the denominator match up, we can have a horizontal asymptote at the ratio of the leading coefficients, which here is just 1. 1 over 1, which is 1. What's the other case? It's either that, or what's the other case? If the degree of the numerator, the degree of the denominator is larger, strictly larger than the degree of the numerator, then the horizontal asymptotes are just 0. Like, for the rational functions we'll look at, there's always a horizontal asymptote, and there may or may not be vertical asymptotes. But the reason I can say that is just because we're forbidding the case that the numerator has a larger degree. Like if the numerator has a larger degree, then you can get slant asymptotes or parabolic asymptotes or cubic asymptotes or all kinds of stuff I'm not allowed to talk about. So anyway, that is like that, sadly. Here's a sad, sad graph. And then down over here, it's going to do something like goes through 0 here, and then it asymptotically approaches that 1. So, sorry, that was not supposed to, I mean, this should be like, if I could draw it better. So just rescaling the stupid thing. Where was that? 4. And then there's a hole in the graph at -4. So there's like a slightly better picture of this. Yeah. Essentially, it's just the reciprocal graph, like y equals 1 over x, right? And it's been done. It's been what? It's been flipped over. I mean, well, it's been multiplied by -1 to flip it over, right? And then it's been shifted up 1 unit and over 2 units. But and then we added a hole in the graph, right? So. I think I've spent entirely too much time on this example. Let's see here, another example. 2, I suppose. F of x equal to x over x cubed plus x. All right, there we go. So this one, we've got x over x times x squared plus 1, right? So this one has, looks like x equals to 0 is a hole in the graph, right? And what's the reduced function here? Right. So the hole in the graph, where is it actually at? It's at 0, comma, f reduced of 0, which is at 0, comma, 1 over 0 squared plus 1, 0, 0 over 1, right? So what's the domain of the function? Sure. Okay. negative infinity to 0. Yeah, 0 to infinity. It's fine. So, I mean, the hole in the graph is at 0 is the point, right? That's where the domain is not defined. Or is not part of the domain anyway. 0 is not part of the domain. And so, what's the vertical asymptotes for this thing? I mean, x squared plus 1 does not factor, right? It's irreducible. So x squared plus 1 is non-zero, right? And how about the horizontal asymptotes? Well, this one has the degree of the denominator is 2. So yeah, horizontal asymptote is just 0. And so this is just that Bell function with a hole at the top. I think this is one of my examples from the previous day. But there you go. It's just now I stuck a hole in it right there. What if you wanted the same graph but with a hole at 1? What would you do? How would you put a hole in this graph at 1? If I want this green graph to look exactly the same, except just have a hole at 1 and then another hole at 3, what would the formula be? Y equals to what? That looks like 2, doesn't it? Fine, at 2. What's the formula? How do you put holes in the graph? If you want to just take a function that's perfectly well and good and just stick a hole in it, what do?
You do like, just like throw parentheses in there and then have whatever you want. X minus.
Yeah.
Would that work?
Pretty much, but you have to multiply by 1. So what you do is put x minus 1 over x minus 1. If you do this, that expression is 1 everywhere except where it's undefined, which is at 1.
And then do the same thing with 2.
Uh-huh. There, I've shown you the secret of how I make examples. Are you happy? So this is essentially a hole puncher. It's like a mathematical hole puncher.
Oh, no, not a hole punch.
Oh.
So every time we see that, we just automatically know there's a hole there.
Well,
If we're talking about this.
in this context, yes. Of course, again, we have to be careful about whether or not the degree of the numerator or the denominator is larger. But yeah. Now, so great. So let me example 3. Suppose I had f of x equal to x squared plus 6x plus 9 over x to the 4th minus 81. And I want to take this upstairs one and multiply it by x minus 4 to the, 10th power. There. Okay, so for sure, I cannot ask you to graph this, right? It is outside the scope of the course, right? But I can ask you a simple question, which is that where is f of x less than 0? Right? In other words, I can ask you to solve the inequality, x squared plus 6x plus 9, parentheses, times x minus 4 to the 10th over x to the 4th minus 81, right? How do we do that? We need to identify the critical numbers. What are they? Can you factor upstairs? What we got? That's x plus 3 squared, right? And let me just write it off over to the side here. What's x to the 4th minus 81 equal to? 3. Okay, well, x squared, I mean, yes and no. It's this times that, right? And there's a 3 involved. And there's a plus and a minus 3 involved, like that. So, sidebar, that's how that factors. Now again, I'm not going to try to graph it, but we can solve this inequality using some of the same principles, right? Which is we want to take the expression and we want to reduce it, right? Like, yeah, we'll use that line technique. But the thing is, before we do that, it's important to like reduce any. So this is like x plus 3 because of that canceled. But the same principle as before, namely that if we have an even overall factor, it bounces. And if we have an odd overall factor, it crosses. That still works just the same. It doesn't matter if the factor is in the numerator or the denominator. That still is how it works. So even factors don't change sign, right? But odd factors flip signs at the corresponding critical points. And so this one, we've got one at where? At minus 3, at 3, and also at 4. And why is there nothing at 9? It's x squared plus 9, right? So that would correspond to zeros of plus or minus 3i. But we're solving this real inequality, so that's kind of like beside the point. So essentially, x squared plus 9 is a non-player in this. It doesn't change sign. It's always positive. Its smallest is 9, actually. Anyway, so then you guys got to plug in a point. Negative 4. Okay, I'll bite. If I plug in minus 4, this to the 10th power is something that's positive. I don't care what it is exactly. Minus 4 plus 3 is negative. Minus 4 minus 3 is negative. I got negative over negative. I get a plus. So to the left of minus 3, I get plus. Let's see here. Another check on our work. We could think about plugging in 0. 0 is between minus 3 and 3, right? So I believe that minus 3, there's just one of those, right? So it should change signs. We should get a plus at 0. Plug in f of 0. What happens? You got 9 over minus 4 to the 10th over minus 81. So that's a plus over minus, which is negative, which is what we expected because oh man, it survived for so long. Minus, minus, minus. And then we've got another flippity floppity here. And then at 4, it still stays positive, right? And so the solution then is minus 3 to 3. And what if I put less than or equal to? Which one gets, if I put that less than or equal to, which one does it throw in? No, one of them's okay. One of them is undefined. One of them is division by 0. One of them is just 0. Did someone say 4? No, I'm hearing things. Which one was it? 3 is excluded, or it's included, right? 3 is excluded, so the minus 3 is the one that gets thrown in for that case. Just remember, avoid division by 0. Think through it.
So it is negative 3?
And negative 3 is allowed. If I plug in minus 3, I get 0 up here. Remember, the thing that you might be getting confused about is.
No, I was just saying that's what I said.
Oh, okay, good. I'm sorry. I hear. It's just me. I just don't hear everything. It's all Jared's fault. I could blame Aaron for me talking so much. Yeah, it's all your fault. I was being ridiculous. That's my signature move. Thanks, guys.